Today we will begin to talk about functions. Functions are equations that involve x and y. For something to be a function, it must have one y value for every x value. So, if we look at what x values are the domain. The domain is a list of x values from smallest to largest. Domain is just a fancy word for saying x values. A fancy word for saying y values is the range. The range is the y values from smallest to largest. So, if we were to look at a table, we would tell that something was a function because for every x value, there can only be one y value. So if I were to have the following table, I could look at it. I'm not looking for proportionality at this point. I'm just looking to see that every x value only has one y value. So this table represents a function. If I look at another table and I'm checking it out, and I look at the values, 7, 6, 8, 2, 3, I notice I check for x values. This x value, -1, has a 7. This x value, -1, has an 8. So -1 has two separate y values. This is not a function. If we are to look at graphs and determine if they are a function, graphs must pass what we call the vertical line test. That means I can draw a vertical line anywhere on the graph. Here's my graph. And a vertical line can only touch the graph at exactly one point. So every vertical line that I'm drawing only touches the graph at one point. So this is a function. Whereas the graph over here if I draw a vertical line, this vertical line touches the graph at 4 points. It can only touch at 1 point. So this is not a function. There's another style that we can look at. It's called mapping. So we can have a list of x values and a list of y values. For instance, -1, 0, 1, 2 for x values and 2, 4, 6, 8 for y values. Each x value can only go to one y value. So this is a function because we can tell that the lines from the x only go to one y. An example of a non-function or not a function, for this one I'm going to use a fancy word, domain, which we talked about domain and range being really our x and y values. So the x values can only have one y value. In this case, we notice that -1 is going to two values. -1 goes to 5 and -1 goes to 7. So that would mean that it is not a function because every x can only go to one y. Yet another way of looking at it is if we're given ordered pairs. If we're given the pairs 1, 2, 3, 4, 5, 6, we can either create a table to check, we can create a graph to check, or we can create a mapping to check. I'm going to create a table first. So I have 1, 2, 3, 4, 5, 6. Every x value only has one y value. So therefore it is a function. If I look over here and I make a mapping, I'm going to use big words again, independent variable and dependent variable, which we know that independent is really x and dependent is really y. I have the values straight from the points, 1, 3, and 5 that are my independent, my x values. My y values are 2, 4, and 6. Every x value, x1 goes with 2, so I'd map it like this. 3 goes with 4, so I go across like this. 5 goes with 6. Every x value only goes to one y value, so therefore it is a function based off of mapping. Or I could graph it, and when I graph it, I'm just going to sketch. The first point was 1, 2, which means over 1, up 2. The second point was 3, 4, so 1, 2, 3, 1, 2, 3, 4. And the last point was 5, 6. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. If I were to draw a vertical line anywhere on the graph, it would only touch one point. So therefore, based off the graph, it is also a function. That is our function intro. On Monday, we will talk more about functions and use the motion detector.